love to have you. Did anyone notice a few weeks ago, a few months ago, when it was really cold, a light that said tire pressure low inside your car? Let's talk about it. The reason why that happened. Oh, that shit. The reason why that happened is, imagine that this balloon is your parents' tire. In the wintertime, when it says tire pressure low, that's because the air outside makes the air inside the tire colder. We just said that when air molecules are warm, they expand. What do you think they do when they get cold? They shrink, they contract. So this is why your light says tire pressure low. But most times when you drive around, it warms the air up and the light goes off. How can I make the air inside this balloon colder? How can I make this air colder? Put lemon juice on it? Interesting. Go to a big cold place? All right, let's see. Come on up, man. I happen to have something that's very cold. Hold this balloon. It's colder than ice. It's really is. Check this out. This stuff is so cold. Check this out. It's so cold that it could freeze my hand. It could freeze my hand. But you can allow it, if it touches your skin like really quickly, but if I put my hand in here and leave it, my hand would freeze and fall off. But if it just falls down, then you're safe. You're safe.
Okay.
But look at the top. Now, what do you think? What do you think would happen? What do you think would happen if we were to submerge this balloon inside the nitrogen? Jacob, look at the take your hands, come over here, and rub your fingers on the balloon. Let's get quiet and make observations. Be careful out here. So, friends, if you listen, that sounds rubbery, right? Yeah. Looking at the balloon, how would you describe or touch it? How does it feel? What is the texture? Would you say it's smooth? Would you say it's smooth? Sort of smooth? All right, let's see what would happen if we submerge it in liquid nitrogen. So do me a favor. Let's see who's ready. All right, let's see who's ready. Scoot back to your spot in 3, 2, and 1. Awesome. Now, come over here, Jacob. Come on this side. Put the balloon in the bowl. And we're going to submerge. We're going to push the balloon down. What is the balloon doing? Take your hand away. What's that science word? That starts with a D. It's deflating. But let's get really quiet so you can hear this. Scoot back. Scoot back. Let's get really quiet so we can hear. Can you hear that? Ladies and gentlemen, it sounds like paper now, right? And the balloon is flat like a pancake. I'm going to show it to you. Jacob, what do you think would happen if we take the balloon out and let the air warm back up? You think it's going to start inflating. The balloon is now flat. So Jacob's hypothesis is the balloon will reinflate. Do you really believe that? If I told you it's the silliest thing I've ever heard, do you still believe that? Let's give him a big hand. Now, the reason why we give them a big hand is because sometimes kids have ideas and their friends might laugh at it. And sometimes kids will change their mind. But like Jacob did, don't ever change your mind. If you believe something, regardless of how crazy it sounds, stand on what you believe until somebody proves you wrong. All right? I'm going to put this water. Notice the bottom of the water in the bottle. I'm going to put that there. I'm going to take that balloon out. Jacob's going to hold this pan and walk around to the front and show you. Let's look and let's listen. Don't touch. Don't touch. Hold up, hold up. Let's look. Yep. Let's look and let's listen. Now. It's regaining its elasticity.
A miracle.
It's we're very careful because that balloon can't pop. It can't pop. But if we're very careful, it will regain its elasticity and reinflate. Let's give Jacob a big hand.
That was a miracle.
That proves that when air molecules are warm, they expand. Remember that water? Look at the bottom now. It has now frozen the bottom of the bottle. Liquid nitrogen is just that cold. Negative 321 degrees. Friends, the craziest thing happened. Scoot back, friends. I'm going to be moving around right here. But the craziest thing happened on my way to see you today. I got to a traffic light after I left getting some gas, and a little bird, I think it was an eagle or a hawk, but it flew to my car, and it landed on my hood, and the bird took its wing out, and it said, I've never heard a bird talk. It said, let your window down. I was kind of perplexed, but I've never talked to a bird before, so I wanted to see how it would go. So I cracked my window about that much, and the bird said, have you ever wondered how I'm able to flap a little bit and fly and glide? And I said no, but there I was flapping like the bird and trying to see if I could glide. But I didn't, right? I had my seatbelt on. But you try it. Flap your arms like this and just glide like a bird, right? The bird said the reason why they're able to do that is because their wings are curved. Make a curve like this. And he said, what did he say? He said, remember this. Sometimes when you're really cold, you might say bird. Say bird. Bird. Sometimes you might get something new. Say new. New. And you might have a friend named Lee. Say Lee. Lee. Bird. Bird. New. Lee. Bird. New. Lee. The bird said the Bernoulli's principle goes like this. If you blow air over a curved surface, you get high pressure and low pressure, and together that gives you lift. I said, interesting. I'm gonna try it out. So the bird said, hey, get a roll of take tissue and try this. So I got some tissue, and according to Bernoulli's principle, this is supposed to happen. What's your name? Come on, stand up for me for a second. What's your name? Say it one more time. Amari, what are you gonna be when you grow up? A scientist. Give him a big hand. All right. Take your fingers and put them through like this right here. Put your fingers through like that, and I want you to blow air over the top. Blow air, and let's see if that tissue will lift up. Is it lifting? No. Keep blowing. Oh, you see that? Now, I wonder what would happen if we use more air. More air. All these principles. We're going to put this on my super duper science blower. Stay in your seat. I want you to hold like this right here, Larry. And give him a real serious look. Stay in your seat. All right? Cut it on in 3, right here. 2, 1. Cut it on. All right, hold it up. Hold it up. sign. Let's see who sees my sign. Awesome. Let's see. Okay, good job. I love the excitement. I love the enthusiasm. It's cool with me. You want to see some more?
Yeah, more paper.
I heard about this guy. He was sitting.
Toilet
We're
paper.
going to just let it stay in your lap, make a ball, and we're going to throw it away later on. But I heard about this guy that was sitting under a tree, and an apple fell down his head. Now, Sir Isaac Newton came up with how many laws of motion? 3 laws of motion. The first law says,
Motion remains in motion.
steps don't keep telling you. Yeah.
An object at rest will stay at rest, and an object at motion will stay in motion unless that acted upon by an unbalanced force.
I love it. Give him a big hand. Now, what's your name? Gabriel. What are you going to be when you grow up? Say again. Playing the NHL, professional hockey. Give him a big hand. Now, his second law says force equals mass.
Acceleration.
Tell him about it. Tell him about it. What does that mean? Yeah, so depending on the mass of the object determines how much force is needed. Hold your hand out. In this hand, you're holding an imaginary bowling ball. Hold your other hand out. In this hand, you're holding an imaginary balloon. If we throw them both up in 3, 1, 2, 3, which one requires more force? Yeah, the bowling ball. Wow. It has more mass. And determine how much mass it has and determine how much force is needed. So his third law says for every action, yes you do? Equal opposite reaction. I'm going to fill this vessel, this vase with water. On top of that vase, I'm going to put a cake pan. On top of the cake pan, I'm going to put a paper towel roll. Sometimes my tables are not level, okay? That worked out perfect. On top of that paper towel roll, I'm going to put a very expensive egg. Very expensive. Now, here's your job. Here's your job. I want you to take this broom, get that broom out. And we're going to practice this first. Let me show you first. So you're going to step on the broom and pull back and let go. You want the broom to go in a straight line and catch it. Put your right foot. Yeah, don't hit yourself in the face. Pull back. Press down harder with your foot. And bring your foot, there you go. Pull back, just pull back and let go. Pull back, let go. Pull back, let go. All right, come closer and stand right here and just hold tight. Now, check this out. This is going to be a really good science fair. Don't do it yet. But this is a really good, if you scoot back, you can see. If you scoot back, you can see. If you scoot back, you can see. Get your cameras out for mom and dad, because you might want to catch this. This will be a really good science fair project or math project on probability. Say probability. Probability means how often can you get the same thing to happen. In just a few moments, we're going to pull the broom back. Don't do it yet. And we're going to let go. Don't do it yet. When we do that, the broom will hit the cake pan, but the broom is going to be stopped by the edge of the table. Which direction do you think the cake pan will go? Point.
There.
Where do you think the paper towel roll will go? Maybe? Okay.
That way.
Where do you think the egg will go? Come closer. Come closer. All right, let's practice. You pull back, I'm going to catch you. With your hand, let go. All right, perfect. Pull back, hold it. If this don't work, I got another option. Hold on. All right, 3, 2, 1.
Oh!
He scored. Give him a big hand. Now, I really need you to scoot back because I need these guys out here to give me to come over for a second. Let's give Scott a big hand. So Scott, I am going to change vessels. I'm going to put this water egg in this cup because, you know, sometimes the science things don't work the way they should. I don't want to break their glass. I'm going to give you this very special rule. All right, scoot back, friends. I really need some space. You're going to put your finger through here. Scoot back, friends. Scoot back. Scoot back. Scoot back. Scoot back. Scoot back. Scoot back. Mr. Scott's going to use his whole arm and make a circular motion, not like this with your wrist, but your whole arm. Be careful to not hit your shin because that will hurt. And then you're going to keep going, keeping the same motion and come to a smooth stop. All right, you practice that. In just a moment, when he becomes an expert with that, I'm going to show you something really cool. Come on.
We're trusting you to not let us. We trust you to not let us.
Let me see it one time, guys. Hold on. Ooh, okay, stop. Smooth stop. Ooh, let's stop being smooth, guys. Now, that same cup with the water. Here's the cup. There's the water, and there's an egg in there. Check this out.
I know it's not going to stand.
It's probably, it is 50-50.
Yep, 50-50.
Let me tell you what I'm going to do. I taught for 20 years, and I learned you can't out-scream children. So what I started doing is talking really low. And then eventually, like magic, all the children got quiet, and everyone was listening because they wanted to hear what I was saying. So in just a few moments, Scott's going to do this board in a circle and something called centripetal force. Say centripetal. It's a center-seeking force. It should keep the cup and the water and the egg on the board without falling off. All right? Say, you can do it.
You can do it.
Look your finger. Lock that finger in there real good. And when you're ready, hold on. Hold on. Hold on. Hold tight. Hold tight. All right, here we go. Go that way. Yeah, go forward. Here we go. Here we go. Egg is being for the speed.
Everybody get a straight line.
All right, get ready.
Everybody let me smash it. It got me too. Look at my shirt. Yo, look at my hoodie. Yo, it got my phone too. It got my phone. I was taking a video. Oh, I'm lucky because I got this. Clean yourself up or dry yourself up with this. I don't want to get hit like this.
Hold it up high. Right here. Same thing. Hold it up high and come over here to where your rod is over the ball. Here I have two mats. Come over the high. Little high. Right there. Now, I need your help. What's your name? Say again. Long. What are you going to give me, girl? Hold it down. A pilot. Let's go, baby. Give me a big hand. What are you going to give me, girl? A pilot. I love it. So small. I want you to hold your magnet over the opening of your rod. Rest your hand, Isabella. And then make sure it's over the bowl. When I count to 3, you're going to drop it. And we're going to count to see how long it takes the magnet to fall through. 1, 2, 3. 1 second. Let's do it again. Hold up the bowl. And listen. 1, 2, 3. About 1 second. Good job. Now, hold your bowl. Hold your bowl. Hold up now. All right. Let's count. 3. Well, no, I want you to drop it just. All right, here we go. Hold it. Let's try it again. Hold it up high. 3. There we go. 2, 1.
1, 2, 3, 4, 5, 6, 7.
Here's what it is. Now, if there's time, I'll show you what's happening. The cool thing about dropping it through a copper pipe, thank you. It's a magnet, but it's not magnetic. So when I drop it through, there's an opposing magnetic force that makes the magnet float down. And it's really cool to look at. So if there's time at the end, I give you all a chance to check it out. All right? Let's give them both a big hand again. Do some more my handy science time. Over here, we have one of my favorite demonstrations. Stay where you are. Stay where you are. Go back a little bit. Come here, champ. Listen up, friends. What's your name? Say again. Uriel. What are you going to be when you grow up? Turn around, look at the crowd, and tell them. Say it with your chest. What you going to be when you grow up? A gamer. Give him a big hand. I love it. So look, I am going to put some Mentos candy inside this tube. Now, on the surface of the candy, let me see if it's going to still work, if the magic still works. If I get lower, let's see if your voice will get lower.
Did you get 2?
On the surface of the candy, there are small cracks called crevices. Say crevice. We're going to drop the candy inside the Diet Coke. The Diet Coke has...
Oh no.
The Diet Coke has carbonation. And we're going to see what happens when that carbonated liquid mixes with the cracks on the candy. Stay where you are, stay where you are, stay where you are, stay where you are. It's okay. Thank you, I appreciate it. Give him a big hand. Because the count is always counting. I appreciate that. Come over here, champ. Because the opening on my tube is small, please stay on your bottom. You will see if you're on your bottom. But if you're standing, you're going to block my friend's view. I want her to see. see. But look, get the cameras out, y'all. This might work. It might not. We're going to see. Hold that screen. Scoot down. Scoot down. Now count to 3. I want you to pull the string. 1, 2, 3. Pull it.